And I'm very excited to be here today to talk to you about some of things that I hold very near and dear to my heart, robots, JavaScript, and drones. And with that, let's dive in. So I run engineering at a company called Tindie out in Palo Alto, California. We'll talk more about what Tindie is and why we exist a little bit later on. But it's important to note that Tindie is a platform. It's a marketplace for people to buy and sell hardware. So this is a software company, fundamentally. Probably like yourselves, I spent most of my career building web applications and desktop applications. And people don't build those anymore. They build mobile applications. So when I graduated from undergrad with my CS degree, newly minted in my hands, I went to work for a consulting firm that was building web applications for large Fortune 500 clients. One of the first clients that I worked for was a healthcare company, and they were building a web application to help their nurses manage some of the patients that had some of the most severe diseases that cost the insurance company the most money. So think diabetes, congestive heart failure. Perhaps this is a problem that rings true with you. So that was kind of my first taste that a web app, the power of the web and the power of software could really change people's lives. After that, I went to work at the Supreme Court of Virginia. I helped build one of the very first ever web-based applications for the police force. So when they bring criminals in to book them, previously the criminals could commit crimes in different counties, but with the power of the web, suddenly the officers could see their criminal records and immediately know if they were repeat offenders. And that was really amazing to me, that these skills that I had learned could actually have these great real-world applications. But several years ago, this started to change. So I really think of myself as a software person. Perhaps you identify as software people as well. Actually, could you raise your hand if you feel like you're a software person? All right, so it looks like about 90% of the room raised their hand. Now, for those of you, who thinks that identifies that they're a hardware person? OK, so we got a little sprinkling here. OK, cool. So don't worry. Software people, I was like you, and hardware people, like, you're awesome too. So, but software engineering to me, throughout the beginning and middle of my career, it didn't mean this. So it didn't mean robots to me. I also never had a situation where I needed to debug a program that involved using a baby pool. So that was kind of like a foreign thing to me. And software definitely didn't mean something delicious that I could eat. This is candy. We'll talk more about that later. And so the world around me was changing. And so around 3 or 4 years ago, I started becoming more and more interested in the role of hardware and especially software that affects hardware. So let's see, we'll do the math. Almost 2 years ago, the New York Times published an article that talked about the hardware renaissance that's going on in Silicon Valley right now. That hardware is being prototyped, it's being manufactured by people in the Valley, although largely this generally occurs mostly in China now, but it's changing. And the first concrete example of this I'd like to show you is this. So this is the Pebble watch. I had dinner last night with a fabulous group of Cerner engineers, and one of them had a Pebble watch on. So the Pebble watch was one of the first smart watches. It was a fantastically popular Kickstarter campaign. If you're familiar with Kickstarter, it's a crowdfunding platform where people can contribute variable amounts of money. And then, if you're lucky, the product that they're raising money for actually works, and they can actually manufacture it, which is a non-trivial task. And then the Pebble watch comes out. So what's interesting here is we see a hardware product, a watch, paired with a software platform. So a very large component of Pebble is the software that powers it and the apps that are then built to be used on the watch. Exhibit B. So I have a feeling you're going to remember this one. So right before Black Friday in 2013, Jeff Bezos, the CEO of Amazon, gets on the very popular news show 60 Minutes to talk about what's going on at Amazon. And Amazon is very often a very closed-door company. They don't like to talk about what they're doing publicly until they release it and it's been announced. But Jeff Bezos says he's working on something kind of crazy called Prime Delivery by drones. So this is a drone, an unmanned aerial vehicle. And the thought is, in the future, a software company, Amazon, is now doing hardware, these drones, to improve the delivery times of select Prime items. And now we've got Exhibit C. So I spoke at a conference in 2013 for a software company called New Relic. New Relic provides monitoring tools to help you figure out latencies within your software stack. For example, are you spending too much time at the database layer? Are you spending too much time on your application servers? And when I showed up for the conference, the badges were circuit boards. So this is my badge for the conference. And what was so cool, that little white thing that you see popping out of the side, that's what's called an electric imp, and it provides wireless connectivity to the badge. So you're basically walking around with something that's connected to the internet, and when you see someone at the conference, you're supposed to swipe badges with them. So New Relic, a software company, then built an app so that every time you mash your circuit boards together, you get points on the app, and whoever got the most points won some pretty amazing prizes. But what's kind of cool about this, and a theme that I like to talk about throughout the talk, is that suddenly wearing a circuit board around your neck was the coolest thing since sliced bread. Now, this hasn't obviously been the case. If you look around your kitchen, for example, you don't see a whole lot of bare circuit boards. You might see a toaster, but there's a circuit board and a microprocessor in that toaster, but it's got a nice, shiny finish to it. But now we're starting to enter the age where software companies are playing with hardware and they're exposing their circuit boards. So again, May 2014, we start to see more talk about what's going on in hardware. Now, I actually get very irked when they talk about this being a Silicon Valley phenomenon. And I'll give you an example why. Tony Hsieh, who was the CEO of Zappos. Now, Zappos is an online shoe retailer. Tony sold the company to Amazon, did very well in the sale, and he moved to Las Vegas. He started a venture capital fund in Las Vegas called the Vegas Tech Fund. And one of his investments is he is now building a large-scale manufacturing facility in Las Vegas. If you're familiar with MakerBot, which is one of the original 3D printers, MakerBot, many of them are manufactured in the United States. That is in the Valley in Fremont, California. But you can see that a lot of this hardware renaissance is coming out and it's leaving the Valley, and it's coming to places all over the United States, and as I'll talk about later, it's all over the world. So one of the big points I want to ask and drive home with this talk is, how did this happen? How did software companies start getting into hardware? How is it that hardware companies now have a very large software component? This is an actual picture of my computer and my Arduino. I noticed this morning that I chose the slide that had no code in the Arduino editor. That was a mistake. I do have code in there at one point, but this is my setup. So how did this happen? And why does this matter to me, to you, to Cerner, to all of us, to engineers everywhere? So how I woke up to this. Let's talk about the present-ish. And now, a blank slide for impact. I think there actually was something on here, but I think I deleted it. OK, so fabulous. So as I said earlier, I really think of myself as a software person. And I use Twitter. Do you all tweet much? A little bit, off and on, when you're bored. And several years ago, I started getting really excited about the notion of geolocation. So when you tweet, you can turn on location on the phone, and this is a tweet that I sent when I was in New Zealand to say, like, good morning from New Zealand, because, you know, it's Twitter, so you have to talk about all the glamorous, amazing things that you do in your life. And so I send this tweet, and I've turned on location. And when someone sees the tweet, they can see there a latitude and a longitude. Now, this isn't particularly earth-shattering, groundbreaking. The thought that a digital artifact, like a Facebook check-in or an Instagram photo or a tweet, something that exists online, can have location, because it couldn't exist unless you were using a device that had an IP address. And if you have an IP address, that means you have a location. If you're interested in this, and I started digging into this because I was kind of intrigued, you can get very good location granularity through an IP address. In the United States, you can get down to about less than 1/4 of a mile accuracy on an IP. So if you have, from your tweets or from anything that you're doing, people know where you are. Now, let's extend that thought. So this is a product from a company called Quirky. It's an egg tray that you put your eggs in your refrigerator. But what's kind of crazy about it is it's connected to the internet. And if it's connected to the internet, your eggs have a location. And this is a product that you can buy. It's for sale on Amazon. It's for sale at Home Depot. And the thought is, if you have a problem where you never know if you have eggs, you can use their mobile app when you go to the grocery store to figure out, how many eggs do I have? Are my eggs old? Have they gone bad? And so, thus, if this is a problem that you have, your problem has been solved. And you can also know, although I think this is not necessarily an advertised feature, has someone stolen my eggs? Have they gone to another location? So I like to call this location as a gateway drug. So we start off with location. I started off getting really excited about location in the software world. And then location now bleeds into the physical world. And this is one of my hypotheses, is that every day something will have location, because one day everything will be connected to the internet. I pay for Pandora, which is a music streaming service. And I was installing the application that you can get if you pay on my desktop computer. Laptop, sorry, that's like desktop, who has those? And one of the choices that they presented to me, Pandora, a software company, was, did you want to play Pandora on your refrigerator? And my first thought was like, my refrigerator really sucks, and like, I don't think that's possible, but that's true today. That won't be true tomorrow and in the future. And so we're starting to see the notion that all of the applications that you use, you often think of them being siloed on your mobile device or on your laptop or on your iPad or on your tablet. But in the future, you're going to be able to use those applications on things like your refrigerator and your toaster and your car. I mean, Tesla, you can already do that. So we're starting to see this bleeding of like, what is a computing device to become everything around you? So this is what's called the Internet of Things. Things being everything that is connected. Now, I like to use the Google Trends graph because you can't, well, I can't make this data up. So Google Trends is kind of proof that I'm not lying to you, that this is actually something that is going on. So you can see in 2007 to about 2011, 2012, Internet of Things, like, it's kind of interesting. People think it's a little novel. And now it's starting to gain momentum as we go into the middle of 2014. So how did this happen? Traveling back in time, meaning before 2010. So if you wanted to create your own circuit board before the 1990s, you had to create a schematic. So I bet that the minute I advanced to this slide, half of you went to sleep. Because this looks kind of, not necessarily, I would say, boring, but to a software person like myself, if I wanted to create a schematic for a circuit board, I would have to read up on a lot of physics and electronics that I forgot a long time ago. I would have to remind myself, what are resistors, capacitors, how do I gauge current, how do I do all these things? So not necessarily hard, but not as a software person, that's not my favorite thing to do. And so this meant that creating your own circuit boards, this is another schematic, was very hard to do. The barrier to entry to create circuit boards and build your own electronics was very high because you had to have a lot of specialized knowledge. So in the 1990s, that started to change. Parallax introduced the first board that you could do some prototyping on. And what was so revolutionary about this board was that it only cost $100. And you could program it in BASIC. How many of you are familiar with the BASIC programming language? Okay, rad. So BASIC is near and dear to my heart. It was one of the first programming languages I learned. And the big sell on this board was that you no longer had to write low-level C if you wanted to do electronics. You could now write BASIC, a higher-level language. And we start to see an interesting trend emerging here as well, where it's a commoditization of a part that's used in prototyping. So instead of having to purchase a specialized board that you've designed yourself, you can now use something that's widely available and costs $100. How many of you are familiar with Arduino? Okay, good amount of people. So up until 2005, people used the Parallax boards pretty often for electronics prototyping. And in 2005, as you see on the slide, the game changed. So Arduino is a small board that's used to do electronics prototyping, as I mentioned before, but it's used in larger scale. You would use it as part of a larger system that you're building. It was created by a man in Italy named Massimo, and he's a professor at a design school, so not an engineering school. And if you think about Italy, in Italy they have Milan, they have fashion, they have pizza, all these like very, very distinguished types of things, very, very like couture. And so when he designed the Arduino board, he made very, very explicit decisions around what it should look like. So it's not a coincidence that it's it catches your eye, it's blue. On the back of the board, you'll notice that he has made in Italy, and he has the country there, and he was very, very careful to have the coastline be perfect. And the reason that he created Arduino is because he was teaching a lot of design students, and he wanted them to start using electronics in their design, but the basic Parallax boards were too expensive, and they were too hard to program for design students. So when he came up with Arduino, he wanted to build something that was much cheaper. An Arduino will cost you $25 to $35, and that was easier to program. So the first set of Arduinos, and you can still program them today like this, they use a language called processing, which is very similar to Java. And I'll talk about a little bit later how you can use even more languages on Arduino. So this really opened up hardware hacking and hardware experimentation to be from people who were very, very highly skilled, very highly educated, had access to a lot of these parts, to anyone could buy an Arduino. And you started seeing projects like stuffed animals that would go online and you could talk to them, and all these kind of wild projects that you didn't traditionally identify with hardware or software, but were bleeding into design and some of these other disciplines. So this changes even more in 2011. So we see the Raspberry Pi, which was created by Eben Upton. He's a professor in London, and he's a professor of computer science. And one of the challenges that he saw was that enrollments were decreasing in computer science. And he was very worried about this, not only from a societal perspective, that engineering is awesome, and we should get more people into engineering. But he was obviously probably a little worried about his job, because if there aren't any students, how would he teach them? So he decides that one of the key problems in this is that students don't have access to computers young enough, because computers are expensive, and you may not be able to afford one, or you may not be able to, you wouldn't know how to buy one. And so he decides that he's going to create the Raspberry Pi, which is a $25 Linux computer. So this is a whole computer here. It doesn't come with peripherals, meaning a mouse or a keyboard or a display. You would need to purchase those. But this is, it's got an Ethernet port. I mean, it's got like HDMI out. I mean, it's pretty sophisticated for being, you know, $25 to $35. So he creates this, this computer with the thought that if it's cheap enough, he can get it into the hands of aspiring engineers and computer scientists earlier and get them really hooked on and excited about computing. So again, we see, like Massimo with Arduino, he sees an opportunity to get people excited about technology, particularly students, and he builds something for the students. So this is the beginning of the fall of the barrier to hardware. Like, the wall is starting to crumble. Access is being opened up to people who did not have access before, whether that be because of cost, because you needed specialized education, etc. So this mirrors what happened with the BASIC programming language. Again, as I said earlier, I'm a fan of BASIC. Maybe perhaps some of you write BASIC today, or Visual Basic. So in the 1960s, if you wanted to write a computer program, you had to use something called punch cards. And you would write your program on the punch cards. And computers were mainframes, and they cost really exorbitantly large amounts of money. And in the East Coast, MIT had several mainframes. And so there were several professors at Dartmouth, computer science professors. It wasn't called computer science at the time. But these professors really wanted their students to be able to run their programs. But to run the programs, you'd have to print out all the punch cards, and you'd have to drive 125 miles to MIT, and then you'd have to deliver your punch cards, and then you'd wait about a week, and then you'd get your punch cards back, and that's how you found out if there was an error in your program. So imagine if that's what you had to do today. Not very fun. So this is one of the professors who created BASIC, and the thought was he wanted to create a programming language that was easier to use and that you could use over phone lines to communicate with the computers at MIT. So he invents BASIC. And instead of saying log on and log off, you say hello and goodbye. And the thought was, let's make it easier for people to get into computing. And what they saw was a phenomenon like no other. So this is the 60s, and suddenly everyone wants to use computers. And this is a fantastic and very important thing, because when you lower the barrier and you get people excited about computing, then this benefits the discipline, it benefits all of us, it benefits large companies, it benefits Cerner, because there are more people excited who want to work in technology. So they actually ran into a problem where the telephone company needed to install more lines because they were all getting jammed up with people wanting to write BASIC programs. So as you can see, maybe this story is long forgotten. BASIC celebrated its 50th anniversary this year. But this is what's starting to happen with hardware. History repeats itself. So I have a good friend who lives in Durham, North Carolina. Her name is Julia Ellman, and she runs a tech camp for teens who don't typically have access to technology. They don't have computers at home, and they definitely didn't grow up with software engineering parents. And so to run this tech camp, she needs computers. But buying a lot of MacBooks, that's really, really expensive. So she bought a bunch of Raspberry Pis, and she set them up in the lab, and the teens came in, and they used the computer, often for the first time, because some of them have like small mobile phones. They don't necessarily have smartphones, but they use the computer, and they wrote Python. It was a Raspberry Pi, comes with Python on it. And it like totally blew their mind. And this is the kids, it's just like so awesome. This is the kids at the end of the camp, like showing off their Raspberry Pis, because they didn't realize that software was so cool, that you could do these types of things. And this is, I think, one of the coolest uses of the technology is that you can again, lowering the barrier of entry. Because this is the future, these are the future engineers. So the examples that I've given you so far are a lot about students and education, which I think is a very, very important part of what's happening with hardware today. But now we're gonna get a little bit deeper on this. So this is actually a quote from one of our investors. And it talks about how often new technologies, the technologies that change the world, they start out looking like toys. So the example that he often gives is the telephone. And when the telephone was first invented, you could only talk to somebody about 100 meters away. 100 meters is not that far. So everybody thought it was a joke because you could basically yell 100 meters and talk to the other person. And so it was largely waved off as a toy or something cute that people would have in their homes, like the nerds and the scientists and the geeks. They'd mess around with the telephone. And obviously, the telephone changed communication. So, Raspberry Pi, let's talk about that a little more. We're starting to see more advanced uses for your Raspberry Pi. One of them is you can use it as a Tor proxy. So if you're very concerned about privacy on the internet right now, remember earlier in the talk I talked about how if you have an IP address, I probably know where you are. Well, Tor is a way to encrypt your web traffic. So there's an article in Make Magazine, if you're interested in doing this, about how to use the Pi as a Tor to encrypt all of your internet traffic. AWS, Amazon Web Services, recently came out with a set of Python libraries and command line tools that will allow you to use your Raspberry Pi to upload your photos to S3. S3 is a way to store any sort of data. You probably use it for static assets in your web applications. But imagine if you could just store all your photos on cheap storage on the Amazon cloud, always backed up, using your $25 Raspberry Pi. So, and now this is the Tapster. So, this is created by a friend of mine, Jason Huggins. If you've heard of Jason's name before, that's because he created the web testing framework Selenium. Selenium is a way for you to spin up a browser and run through a bunch of web tests by clicking on a bunch of buttons. The tests will do that for you. You have to write them. But why Selenium is important is as we move into the age where we're using a lot of JavaScript frameworks, where HTML is generated client-side using JavaScript, it can be very hard to test that code on your back-end servers. So Jason wrote Selenium, and he's a testing nut, like he loves testing. But he also really loves robots. So this is a robot that plays Angry Birds. Now, you laugh. I mean, Angry Birds is a little 2012. I get it. And maybe it plays like dots or something like that now. But what Jason did, and this is using Arduino, is Jason built a mobile web testing framework. These robots are used in large Fortune 100 companies to do mobile testing. They're completely open source. And in the hardware world, it's open hardware. You can make one of these yourself, again, built on Arduino, open hardware. And so it's kind of amazing, the things you're starting to see and do with technology that was designed for students. So these are signs of early maturity. These are signs, one of the coolest things is when you build something and someone uses it in a way you never could have possibly imagined. And this is what's starting to happen with a lot of these prototyping hardware technologies. Like I said, advanced uses you never thought of. So here's another example of something crazy that's happening. How many of you write JavaScript? Cool. So a good number of you. So, as I mentioned before, if you want to program on an Arduino, you're using a language similar to Java called processing. Now, I don't know if you're like me, but I have my favorite programming languages. Processing is not one of them. I'm not really interested. Learning it could be kind of cool, but that's not really something I want to do. Like, I want to write my favorite language, when I program hardware. And so, what's cool is that now some of the boards, like Arduino, allow you to put a firmware on there that enables you to write any programming language. So this has given rise to the phenomenon called node bots. So when I say that says note bots, it's supposed to say node bots by mistake. So when I say node, you say, oh, that was fantastic. I didn't think you would say bots. I thought you would say JavaScript. But good job. Give yourselves a round of applause. That was great. The unexpected parts of giving a talk, things you never thought would happen. Okay, so these robots are programmed using Node. So Node is a library for JavaScript to write server-side JavaScript. So these little robots, they're open source libraries, and people are coding in JavaScript to run these robots. And this has given rise to the JavaScript robotics movement. So this is the movement also has what would the word be? This is Johnny 5. He's the icon of the node bots movement. So, and the thought here, Rick Waldron created this. The idea is, wouldn't it be cool if you could control not only your robots, but your entire home, your lights, your fridge, your stove, using JavaScript? So half of you are probably excited, and the other half are probably horrified by this. I feel like I'm like in the middle. So this is a piece of pseudocode that thinks like, okay, what if you could locate your living room like you'd find a node in the DOM. You find your living room, and you turn on your lights or dim them. And this very much follows Atwood's law. So Jeff Atwood created Stack Overflow, one of our favorite, as engineers, one of our favorite Q&A sites. And he issued this edict to the world that one day, anything that will be written in JavaScript will be written in JavaScript. So, what's my role in all of this insanity? So in the fall of 2012, I get a phone call. It's from a friend of mine who had started Tindie, which is where I am, as a nights and weekends kind of deal. And he had been hanging out a lot on the website Reddit. So if you're unfamiliar with Reddit, it's kind of hard to describe. I would call it a set of forums where people can hang out, they can talk about topics, they can post GIFs, very large use of Reddit. But there's some sub-forums, or as they're called, subreddits, that are very heavily used by the engineering community. There's one for Python. Python is my favorite programming language. And there's also one for Arduino. So Emil, my friend, was hanging out in our Arduino, that forum, and he was seeing a lot of the things that people were building with Arduino. And what he started to notice is that people built some really cool technology, but they didn't then do anything with it. Like, they didn't know where the community was. They didn't know if they should sell it. They didn't know if anyone else on the entire earth would ever want to buy some of the things that they had made. And so he gets this kind of crazy idea to start a marketplace for people who are building on top of Arduino. And he, as I said, he starts this kind of as a nights and weekends thing. And then it starts growing, and it starts growing, and it starts getting bigger. And so by the time he called me in the fall of 2012, it was already at the point where he needed someone to take over all of the engineering, to build the engineering team, to build a production system. Because as you probably know as engineers, the stuff that you build on the nights and weekends, it's probably not then ready to become an immediate production system. So after many long conversations, I joined Emil as the first employee of Tindie and head of engineering. And this is Tindie V1. So it was all about buying and selling homemade tech. So we're a Python shop. We use the Django web framework. We run on AWS. And we had several products ranging from some heat sinks for your Raspberry Pi. So if you start getting really, really into Raspberry Pi, you can overclock your Pi, and it can get really hot. And so one of our makers in Europe developed some heat sinks. So you put the heat sinks on, and then you can continue to run your Pi at a very high rate. And what's kind of cool is that from day one, we had 27 countries. People were buying in 27 countries, and we had people selling in 14. So I think the fourth order on Tindie, the first three were to the US, and the fourth was to Germany. So the hardware movement is very much from day one an international movement. So Tindie starts to grow. This is like, we ship code every day. And so this is Tindie. Who knows what version this was? This was like in the fall of 2012. And this is what we look like today. And what's kind of amazing is, in building a software platform, there's a lot of things about hardware that I learned that I had never knew before. For example, last fall in 2013, we had a seller in the UK list this. It's an AirPi. So this is a kit that you would use with your Raspberry Pi. And it senses anything in the weather that can be, in the environment that can be sensed. So think of like temperature, humidity, barometric pressure, all of this. Completely open hardware. So you could print your own board if you want. It comes as a kit. You solder it together. And then what's cool is that you connect it to the internet, and you can share weather data across the world. So we're like, okay, this is pretty rad. If you wanted to build a weather station before this, it would have cost you hundreds, if not thousands of dollars. And this is under $100, so $90. We're like, wow, that's pretty awesome. And like some time goes by, and it's selling, and it's selling really, really fast. And within 2 weeks, he sells $30,000 of this. And it gets picked up by Raspberry Pi, and they're promoting it. And so we talked to him. So I don't, we have thousands of sellers. I know a lot of them. I don't know all of them. So we reach out to him, and we're like, hey, this is like really amazing. How can we help you with this? And it turns out that he's 18. And he built this with another student as their science fair project. And now we need to give him $30,000 through PayPal. So software problems in a hardware world. And so this was kind of mind-blowing that teenagers can build something like this, and he had no idea what the demand would be. And so we started seeing parents buying this to make with their kids. We started seeing institutions buying this to be used in the classroom as part of their classes. And now I talked a little bit about Tapster, the mobile testing platform. So about Jason, who quit his job because he wanted to build robots full-time, and he never thought he could until he started selling them, and he realized there was a large amount of demand. This is a much more polished version of the Tapster. It's grown up. And now we see buyers in 80 countries, sellers in 50, and new countries are coming online every day, buying and selling. The majority of our business is not in the United States, which poses a lot of very interesting internationalization challenges. It also poses challenges in handling shipping from a lot of different countries. several weeks ago, I had to determine the tracking URLs for 45 different shipping companies. 25 of them were not in English. So again, interesting software problems. We've got thousands of products. And now think about this. So the Raspberry Pi, when it came out, in something like 16 months, it sold 2 million units. And it's sold out in the United States like within days. In 2012, we started seeing the electric amp, which I managed before, which allows you to put wireless on everything. SparkCore is the same thing. If you wanted to put wireless on this water bottle, you could attach a SparkCore to it. It would have an IP address, and then I would know where my water bottle was. So this is part of the larger trend of we're seeing all these Internet of Things technologies come out. They're selling out. SparkCore was a Kickstarter, massively exceeded its goal. It's now a venture-funded company in Silicon Valley. And the original Arduinos were made with Atmel chips. And in 2013, Intel said, hold on. I mean, obviously, Intel is a very big player in the chip space. And they said, we want our chips on Arduinos. So they released the Galileo, which has this Intel chip. And so they understand now that there is something to this Arduino movement. Intel, the large public company that it is. And now in 2013, I'm super, super psyched about this. This is shipping next month. This is a board that allows you, so on the Arduino, your code is compiled to C. On the Tessel, you write JavaScript, and there's a Lua compiler on the board. So there's no more C translation. This is 100% pure JavaScript that you're doing. And so this board, I think, is going to be fantastic for JavaScript robotics, for JavaScript home automation, for all those types of things. So this is actually a picture of the Tessel boards coming off the manufacturing line. So as I said before, you used to hide your circuit boards, and like today, you walk around flaunting them. So you're probably thinking to yourselves, like, this is pretty cool, but I'm a software person. Like, I don't really mess around with hardware. Maybe I want to, and I don't know how. So this part of the talk is for you. So if you were asleep before, you can wake up, and then I'll show you how to get in and start doing hardware. So I created, about 7 months ago, the Textuino. The Textuino is written in Python. Again, my favorite language. This is my computer with actual Python code on it. Not too much, but just enough. And the Textuino is a Arduino that you use to send text messages. So you press a button on the text on the button that you have on your breadboard, which is the white board there, that's connected to the Arduino, that's connected to your computer, that's running whatever language that you want. You press a button, and it sends you a text message. And it sends you a text message using software called Twilio. Twilio is a company that provides some great set of libraries for you to programmatically send people text messages. So this is a picture of my phone where I ran the program, and it sent me a text message, which was pretty fun. And then I'll show you, Boris, if you're interested in doing something like this, if you go to bit.ly/hardware hacking, there's code, there's instructions, there's all that sort of thing. I can tweet it out later if you're interested. It's a really great way to, I think, start doing some stuff, mess around with a breadboard and Arduino. And I would just caution you, if your button gets jammed, you'll send yourself a lot of text messages. And this is something that happened to me, and it's kind of I find it, debugging hardware in the real world is kind of a little bit of an adventure sometimes. And so this is the case where this had happened. So something to think about. So I posted this it got posted on Reddit, and so my website, not a whole lot of views. It gets hundreds of views a day, and I get emails from people reading this tutorial all over the world who want to use Arduino, who want to understand hardware, who want to blend their software and their hardware experience together. So in the fall, I presented the Textuino at a women's hardware hackathon in San Francisco. So perhaps something to consider for maybe future DevCons. There was, all of the women attending got a kit with the Arduino, breadboard, like a bunch of different wires, like some cool flashing lights, some buttons, some things that made noise, and they spent 2 days doing some hacking. Some of the things that were built included a sensor for when someone checks in code that breaks the build, because I feel like we've all had that problem, and we've all gotten text messages, emails. But what if you just had something a light that was blinking and then maybe made some noise? Like kind of a cool way to tie the physical world with the software world. 2 days of hacking. And so this is something, I'm going to show this video that one of the women created. So she has a leap motion controller, which is under her hand. So the controller senses gestures, and what she did was she wrote a program that interpreted the gestures and moved the robot accordingly. So if you see, like, so this is go forward, sideways, backwards is extending the fingers. So she did this in 2 days. I mean, the controller already had the hand sensing, but she wanted to map that to make the robot do something. So I thought this was pretty amazing for somebody who had almost no hardware experience. Like, she's a software engineer, but now she's building something like this. So she actually has all the code. Oh yeah, and then this stops it. Now we get this nice close-up of the robot. So she has all the code on her GitHub. It was pretty amazing to see something like this demoed at a hardware hackathon. And now the JavaScript con last week, there were some pretty cool things that went on, including like a very large-scale like NodeBots tutorial. And they had a 3D printer there to print out some parts for the NodeBots, so they're cutting them out. And then they had a NodeBot soccer. So this is, all these robots were made by people at the conference. And they're trying to play soccer. You'll see there's a very, see the robot fell over. That's kind of a common problem when you're playing with the NodeBots. Someone has to turn it back over. But then now he's going to try to kick it. Like he's spinning his robot to try to kick the ball into the goal. Oh, it's so close. Is he going to do it?
Got a forward on charge.
So then they have soccer. And this is all with JavaScript. And so they keep playing, and like they have this really cool soccer game. And you see people of all ages participating in here. So I've talked to you about what's happening, what the past, now we're in the present, and now let's talk about the future. So this is 3D printed candy, and this was made by a couple of architecture students that were really interested in the properties of sugar and how to build structural sugar for baking and for displays. So they created the Chef Jet, which is a 3D printer for this. You can buy this candy online today if you want for your party or developers conference event. And here we see, when you think of 3D printing, you often think of plastics, or you think of metals. And now there is food. Now, this is a cast that someone has created. So if you break your arm, it's a 3D printed cast that snaps together. Those two wires going in simulate the bones to increase healing. So what if in the future, instead of having those like nasty casts that you used to get, I mean, hopefully as a kid and not as an adult, but you would have to like scratch your arm with a wire hanger. I don't know if you remember that. If you don't, that's good. But what if you just printed a cast? And these casts are very, very strong, especially if you're using industrial-grade plastic. So this is not available yet, but I think this is where a lot of medicine and technology is going, the whole med tech field. And I want to talk a little bit about some more things about Maker Faire. So Maker Faire Kansas City is coming up. It is coming in a few weeks. I would really encourage you to go. It's pretty amazing. They have some really great technologies. I go to the Bay Area one every year. But the reason that I'm bringing this up, not only because I'm in Kansas City, is because of the maker-nurse movement. So there's a really, really sharp woman who's at MIT who realized that if she could bring the making movement into medicine and show the maker movement to nurses, there might be some really cool synergies that would come out of that. So when we think of Maker Faire, we typically think of Maker Fairs in cities, but she did the very first medical Maker Faire. So she brought a Maker Faire into a hospital. And this is a hospital, and she's at MIT, and she's working at a device lab there, and this is a hospital in the Boston area. So in true kind of crazy Maker Faire fashion, there was this 6-foot-tall animatronic robot man that was brought in on the gurney that you could then test out some of your crazy medical ideas with. Here's some pictures of the nurses doing some stuff with this mannequin. Here someone has created something that they are testing out with the mannequin. And the idea is that the maker movement and this whole idea of hardware and reducing barriers, this isn't just for engineers. Like, this is spanning in with healthcare professionals as well. And if you're interested in knowing more about this, you can go to Maker Nurse. I think it's .com. It might be a .org. I can't recall. Or you can ask me about it. And so I think what's really amazing is you see people who typically aren't associated with this maker movement or wouldn't self-identify as makers, but they're building things and they're participating in ways that nobody had thought was possible before. So I want to leave you with the thought that this is just the beginning. There are so many more technologies that are going to come out of this, that are going to come out of the reduced costs and the reduced barriers to hardware and to software. And so with that, I want to thank you very much. Send me a tweet if you want to, if there's anything else, any other questions, and I really appreciate you chatting with me today.